Hello guys, welcome to another video in the series of coding. We are going to do the last problem in this contest. It's called build a matrix with conditions. Let's see. So we are given some row conditions and column conditions. So let's say these are row conditions and these are column conditions. So let's first see the row conditions. So it means that 1 should come before 3, the element in let's say this is our matrix. So among all the rows here, somewhere the element 1 should come. It should come before 3, right? So let's say 1 is placed at this row. It should definitely be before the element 3. Let's see the next condition, 4. So 4 should come before 3. This is the next condition. So we cannot place 4 after 3. 4 has to be somewhere before 3. And then there is this condition also, 3. 3 should come before 2. So then if 3 is here, 3 should come before 2. So this is how you can place the matrix. So it's a 4x4 matrix only because there are 4 elements that is given. So this is how you are supposed to make the 4x4 matrix. That means in the first row you can place the element 1, in the second row you can place 4, in the third row you can place 3, and in the fourth row you can place 2. Okay, so these are the row conditions. Now let us see the column conditions. Okay, so according to the column conditions, these are the conditions. So you have columns. So this is a 4x4 matrix in which you have columns, right? So let me do one thing. Let me just draw the columns for simplicity. So you are given 1 should somewhere come before 2, right? So 1 should come somewhere before 2. Then you are given 4 should come before 2. So 4 can come here, or 4 can come here also. So anywhere it can come, but it should just come before 2, right? So that means it should be on the left side if 2 is on the right side. Okay, like this. And then let's see 4, 3. So 4 should satisfy the condition such that 4 should come before 3. So 3 can come here, or 3 can come here, or 3 can come here. That we will have to decide right now, but 4 should definitely come before 3, and so on. So these row and column conditions, both of them should be satisfied, right? So how are we going to solve this problem? So you can see that these are all linked, right? So easily what you can do, you know that there are connections. So let's see from the very beginning. So it is given that 1 should come before 3. So 1 is connected to 3. So we should ensure that first we travel 1, then only we can go and fix the value for 3. Next, there is a connection between 4 and 3. So first 4 should come, then 3 should come. Then there is a connection between 3 and 2. So first 3 should come, then 2 should come. This is the graph for the row condition, right? Let's similarly make a graph for the column conditions. So in the column condition, you can see first there is 1, and then 1 is connected to 2. Here there is 4 is connected to 2, and here there is 4 is connected to 3 also, right? So this is your column graph. Now what is the use of making this graph is, now you have to ensure that you place them in order, right? So first of all, if there is ever going to be a cycle, for example in this condition, you see that let's see this example. It is given that from the first two conditions, in this example 3 has to be below 1, right? Because let me try to draw this graph. So here we can see first 1, these are the row conditions. So first you should get 1, after 1 only you should have a 2. According to second condition, you should have 2, after 2 only you should have a 3. But according to the third condition, you should have 3, after 3 you should have 1. But how is it possible? Because 1 is already before 3, right? So this is not possible. You cannot make a cycle. So if there is a cycle in a graph, it is going to be wrong, right? So if there is a cycle in a graph, that means cyclic conditions cannot be allowed, because how can 1 come before 3 and also come after 3? This is not going to be allowed, right? So because of this, we can check cycle. So you can use topological sort algorithm to solve this question. So let us see that. So these are the graphs that we have made for row and column conditions. Now let us use Kahn's algorithm, which can be used for solving this problem easily. So what is the topological sort algorithm? You have to see whether you can finish these processes and there is no cycle, right? So if you are able to finish all these processes without any cycle, right, and if there are k elements in the process, because you have to make a k by k matrix, that means that your all conditions are satisfied. So we can start from any of these conditions. So what happens in Kahn's algorithm, there is something called degree, where degree is just the number of nodes pointing towards you. For example, for 3 there are 2 nodes pointing, so the degree for this is 2. For 1 the degree is 0, for 4 the degree is 0, for 2 that there is 1 node, so the degree is 1, right? So first let's make this graph. So once we make this graph, you can start traveling from any node which has a degree of 0. So for example, this node 1 has a degree of 0, right? So first you can visit this easily. So in the row condition, first at the first row you can place the value 1. You can easily place the value 1, it has a degree 0, okay? After this is done, what you are going to do, since this dependency is gone, what you can do is you can reduce the degree of this, and you can make the degree of this to be equal to 1, right? So because there were 2 nodes pointing at 3, but once what happens is this node is gone, you have finished processing this node, you have placed this node in the first row, what you can do is this dependency is gone, so the degree of this reduces. 2 minus 1 is equal to 1, so the degree of this becomes equal to 1, okay? Now the next node with degree 0 is 4, right? So in the second row you can place 4, okay? So in the second row we will place 4. In the first row we can place 1, in the second row we can place 4, right? So it's not necessary they are going to be unique solutions. You can also get different solutions, but this is one of the examples, okay? So this is also gone. So once you place 4, this is also gone. So because this was a dependency on this, the degree of this will reduce. Now the degree of this also becomes equal to 0. So you can place the node 3 next. So once this is also gone, this dependency is gone, the degree of this becomes equal to 0. Next you get the node 2, so you can place. So you can see that you have got these as your conditions. Now this is very helpful. This is your final condition. In row 1 you can place 1, in row 2 you can place 4, in row 3 you can place 3, and in row 4 you can place 2. You have got these 4 values in line. So this is amazing. There was no cycle. You have finished processing all the 4 nodes, and in row 1 you can place 1, row 2 you can place 4, row 3 you can place 3, and row 4 you can place 2. You have got all the correct values by order. So very easily using topological sort you can find the order where you need to place the elements. Let's do the same thing for columns, right? Let's do the same thing for column. Okay, so this is the column graph. So let us start and do the same thing. So very simple. First just list out the degree. So you can see that for node 2 the degree is 2, for node 3 the degree is 1, for node 4 and node 1 the degree is 0. Okay, so you can start from any node with degree 0. We are finding out the order of placing the elements column wise. So first you can see that node 1 has degree of 0, so you can finish processing it. When you finish processing it, its dependency reduces, so this is gone. So it was causing a dependency on node 2, so the degree for it can be reduced and made as 1. So now you can see the next node with degree 0 is 4, right? So in the second column you can place 4. So now this is also gone. Once this is gone, the dependency is also gone. So this node has a degree of 0 now. So next node with a degree of 0 is 2. So you can place 2. So now you can see this dependency is also gone, and this was already gone. So this dependency was also already gone. When you cancel 4, this dependency was gone and became 0. Okay. So now you can place node 3. Okay, so everything is finished processing. So for column you can place this in the order. So you can place 1, you can place 4, then you can place 2, then you can place 3. So this is the order for the column. In the first column you need to have 1. In the first column and first row you need to have 1. In the second column you need to have 4. In the second row you need to have 4. Again it's not unique, there can be other solutions. In the third column you have 2, and in the third row you need to have 3, and so on, right? Now you can build the matrix. How can we build the matrix? We have got the conditions, right? Now how can you build the matrix? See what you can do. You have this order, right? 1, 4, 2, 3. Okay, we have this order. If we have this order, what we can do, in a map we can store the order. That means these are the values. In the 0th column you need to place 1, in the first column you need to place 4, second column you need to place 2, third column you need to place 3, right? So this you can store it in a map correspondingly. Now what you can do, you can iterate over the row values. In the first row you can see that you need to place 1, but where should you place 1? 1 you should place at the 0th index, right? So here you will place 1 in the matrix. Okay, next you are iterating over 4. So where should you place 4? 4 you should place in the first index, right? So here you can place 4. Now you can iterate over 3, but where should you place 3? You need to place 3 at the third value. So here you can place 3. Next you iterate over 2. Where do you need to place 2? You need to place at the second. So this is one of the possible solutions. Again, it's not a unique solution, but this will be a matrix that will satisfy, and this will give you the answer. Okay, so now we can move forward to coding it. By the way, the time and space complexity will be order of k square, right? So this is the matrix that we have to finally build. Okay, let's see how we can build this matrix. So okay, so it's very easy. You need to create row order and you need to create column order, right? So we can use the Khan's algorithm. So I'm going to declare a function called Khan, and I'm going to pass the row conditions and the column conditions in this. So I have the row conditions and I'm going to pass k also to it, and similarly I'm going to make the vector for the column order. Okay, so this is the vector for column order, and this is for, again I can pass the column conditions in it and I can give the value of k. Okay, so what is the row order? After processing I will get 1432, right? In this example 1432, okay, for example, and the column order after processing I will get 1423, right? This is the row order and the column order that I will get. So let's see the Khan's algorithm. So it is very simple. It has to return vector int. The algorithm's name is Khan. Okay, and what it is taking? It is taking the conditions. Okay, it is taking the conditions that it has, and we are going to make a graph from these conditions, right? And then it's taking another value k. Okay, so so when you have the conditions, okay, let's take one example. What were the conditions that we took? We took these conditions, right? 1 3 4 3 and 3 2. Okay, let me take the example. So the conditions that we have 1 3 4 3 and 3 2, that means it's just a graph, right? So you have to build a graph. So let me declare graph. So let's build graph. And by the way, the values, suppose there are 3 elements, so the value will range from 1 to 3. Value can be between 1 to 3. So here I can pass k plus 1 so that it doesn't go out of bounds. Okay, okay, now I can build the graph. So so this is the graph. Okay, now what I can do in this graph, by the way, I also need a degree vector, because as discussed, we need to find the degree of elements so that we know the order in which we have to process. In the Khan's algorithm, whenever the degree is 0, you can process that node. It has no dependency. Okay, so we need a degree also. So initially we will give degree as 0, and we will see how to give the degree in the Khan's algorithm. So what we can do, we can iterate over the conditions vector. So let's iterate. So for vector int condition in conditions vector that is given to us, see what we have condition of 0, right? This is, so from 1 to 3 there is a directed edge, right? So in the graph what we can do, so graph of condition of 0 dot pushback condition of 1. That means that first you need to process 1, you need to place 1 in a row before 3, right? Same applies for column. I'm just taking example of row. You need to place 1 first, then only you can place 3. 1 should be placed above 3, right? So this is the order in which you need to process. So once you do this, there will be a directed edge from 1 to 3, right? So this is the meaning of that. And when you are doing this, 1 is leaving a dependency on 3, because unless you process 1, you cannot process 3. First you need to place 1, after which only you can place 3. You need to place 1 above 3, right? So the degree of 3 will get increased. So the degree of this element will get increased, okay, by this. So this will be done, right? So the graph will be built. Okay, so after all this processing, let's see what will be the output. Okay, let's see our graph. What will happen? You will have 1 will have a edge towards 3, and then you will have 4 will also have a edge towards 3. I don't know how to write it. Let me try writing it. So okay, just consider this. So this is edge 4 is having an edge towards 3. Let me instead write like this. Okay, so just trying to build the graph. So 4 is having an edge towards 3, 1 is having an edge towards 3, and 3 is having an edge towards 2. So 3 is having an edge towards 2. This is the final graph for the row conditions, right? After this processing, this will be the graph that you are building. And what will be the degree of the elements? So let me write the degree vector. What will happen? What is the degree of 1? The degree of 1 is 0. Okay, and what is the degree of 2? The degree of 2 is equal to 1. There is one node, one edge going towards it, right? What is the degree of 3? Degree of 3 is equal to 2, actually it's a directed edge. Let me just try to make it directed again so it's not confusing. Okay, so this is actually it. So you can see that there are two edges pointing towards 3, right? So the degree of 3 will be equal to 2. And what is the degree of 4? There is no edge pointing towards 4. This is a directed edge towards 3. Okay, so keep a note of that. So it will be 0. So this will be the degree vector. The degree of the element 1 is 0. The degree of the element 2 is equal to 1. There is one edge pointing towards it. The degree of the element 3 is 2. There are two edges coming from 1 and coming from 4. There are two edges pointing towards 3, right? So the degree of the element 3 is 2. The degree of the element 4 is 0. There is no edge coming towards 4. Okay, there is an outgoing edge from 4, but there is no edge coming towards 4. So the degree of 4 is 0. Okay, so this is the degree. After all this is done, what you are going to do? You are just going to apply the Kahn's algorithm. Okay, so how is the Kahn's algorithm? What you do? You basically take a queue. Okay, and in the queue, so you have a queue int queue, and you are going to push the elements which are having degree 0 in the queue. So let's iterate over the degree vector. So for int I equal to 0, I less than k. Okay, I plus plus. You can start from I equal to 1 because actually no element is having a value of 0. All elements are within I to k, right? And so that doesn't go out of bounds. Already we have given k plus 1, so that this will give the correct conditions, right? Okay, so what will happen? You can just see if degree of any element is equal to 0. So if degree of any element is equal to 0, you can just push it in the queue. You can start processing that element, right? So queue dot push that element. So you can push that element, right? So once you have pushed that element, what will get pushed in the queue? So currently in our queue, in this example, there are only two elements which are having degree 0. Which are those elements? 1 and 4. So in the queue you will have the elements 1 and 4. Now you can write while not of queue dot empty. So keep processing the edges, keep processing the nodes. So let me write node is equal to queue dot front, so the topmost value. So for example, let the first value in the queue, let's say it is equal to 1, right? So what you are going to do? You are going to first of all pop it, and you are going to visit the neighbors of 1, right? What are the neighbors of 1? 1 has only one neighbor, 3. So visit the neighbor of 1. So for int neighbor in the graph of 1, so graph of the node, you are going to visit the neighbors of 1, and you are going to try to process them. So what you are going to do? How do you process them? You go and reduce the degree, right? So what you are going to do? Degree of neighbor, you are going to go and decrease. So degree of neighbor, just go and decrease. Now if the degree of neighbor becomes equal to 0, that means you can process the neighbor also. Very simple. Whenever the degree is 0, there is no dependency, you can process that node, right? You can place that element in the row. Okay, if the degree is 0, very good, you have found that position of the element, you can place it, right? So it's as simple as that. So if degree becomes equal to 0, you can just push that element, push the neighbor in the queue. Okay, as simple as that. So what will happen? First you have the node 1. Okay, let's see a dry run of this. First you have the node 1. You are going to visit the neighbor. What is the neighbor of 1? The neighbor of 1 is 3, right? This is our graph. This is our graph. So the neighbor of 1 is equal to 3. Okay, so what will happen to the degree of 3? Degree of 3 will get reduced. You can see that the degree of 3 is equal to 2. It will become equal to 1. So after this will be the degree. Now is the degree of neighbor becoming equal to 0? No, it's not becoming equal to 0. Okay, so we will continue. So by the way, what we can do, when we are processing an element, we will also store it in our answer. So whenever we are processing an element, we will store it in the answer. Okay, so initially the first element that we have processed is 1. Till now we have only processed one element, which is 1. So we will store it in the answer. Okay, now let's continue. So this is the degree vector. Now what we will do? What is the next element in the queue? The next element in the queue is 4. 1 has got popped. Only 4 is remaining in the queue. So the element in the front is equal to 4. So we will process it. So we can store 4 here in our answer. Okay. Now we are going to visit the neighbors of 4. 4 has only one neighbor, 3, right? So 4 has a neighbor 3. The neighbor's value is equal to 3. We are going to go and make the degree of 3 equal to 0. So degree of 3 is equal to 1. It will become 0. Once the degree becomes equal to 0, you can push 3. So the next value in the queue that you will push is equal to 3. So we will push 3 in the queue. So what is the front in the queue? Now we have 3. So we will process 3. In the answer also we will store 3. Now what is the neighbor of 3? 3 has one neighbor 2. So 3 has a neighbor 2. Now we will go to element 2 and we will reduce the degree of 2. So degree of 2 is currently 1. It will get reduced and become equal to 0. So the degree has become 0. So if the degree has become equal to 0, you will store it here. So next time you will process the element 2 and this will be your answer which you can finally return, right? So that's it. This is a simple thing. After which your queue will become empty and you will pop the element 2 also, queue will become equal to empty, so you can return answer. So this is the simple code for the Khan's algorithm. Okay, once this is done, now you have similarly made the row order and column order. Now it's very simple, just declare a map. Okay, unordered int, unordered map int m. Okay, now what we are going to do, see, we have got the row order and we have got the column order, right? We have got both the values. Now what we can do, we can iterate over, okay, let's say we iterate over the column order. So for int I equal to 0, I less than k, I plus. By the way, before this we can also check if there was a cycle. How can we check cycle in Khan's algorithm? If you are unable to process all the nodes, there was a cycle, right? So you can just check if row order dot size is less than k or column order dot size is less than k. That means you are not able to process all the nodes. Okay, then in this case there was a cycle, because if there is a cycle, okay, let's see why is this condition. Okay, let's take this example. Okay, let's say there is a cycle. Okay, let's say there is some node like this. Okay, now there is a cycle, you can see clearly here is a cycle. So what will happen in this condition? What is the degree of 1? The degree of 1 is 1. Sorry, the degree of 1 is 2. There are two nodes pointing towards this. So here the degree is 2. What is the degree of 2? Here the degree of 2 is equal to 1, right? Let me write the degrees here. What is the degree of 3? There is one node towards it, so degree is equal to 1. What is the degree of 4? The degree of 4 is equal to 0. Okay, so these are the corresponding degrees. Now let us see what happens when there is a cycle. So if there is a cycle, how you can easily detect this? First you will start processing the node with degree 0. So you will start processing the node 4, right? So you will process the node 4. Okay, it has a degree of 0. So you will, once you process this, you will go and reduce the degree of this, and the degree of this will become equal to 1. Okay, and this is popped out from the queue. Now you can see that there is no node at all with degree 0. So you will not push anything in the queue. If there is no node with degree 0, what will you push in the queue? Nothing. So that's it. You will exit. There is no element in the queue. You will exit. So you have processed only one node in total, right? You are able to process only one node. You processed only 4. All these elements you couldn't process because none of these elements has a degree of 0. When there is a cycle, this will happen. So if none of the elements had a degree of 0, which were part of the cycle, what will happen? You will not be able to push them in a queue. So the size of this vector that you will get, which is the number of elements that you process, will be less than k. So when this happens, you can just return empty, right? Okay, you need not return anything. There was a cycle detected, right? Now we can declare answer, and answer will just be of size k cross k. Okay, now let us continue. So we have made okay, let's continue. What we did, we have a map, right? Now in this map, what we are going to do, we have for example, we have the column order, right? So we have made a map corresponding to this. Let's make a map. Okay, so I'm going to push the positions. So corresponding to the element 1 in the map, let me write what I'm doing in the map. This is my map. In the map, I am storing corresponding to element 1. 1 should be 0th column, right? Similarly 4 should be in the first column. So I am storing these values in the map. Similarly 2 should be in the second column. Okay, and 3 should be in the third column according to my row and column, according to my column conditions, right? So 1 should be in the 0th column, 4 should be in the first column, because this is the order that I have got according to the Khan's algorithm. This is the order. First I should place 1, then only I can place 4, then only I can place 2, I can place 3. This is from left to right, right? So 1 should be at 0, 4 should be at 1, 2 should be at 2, and 3 should be at 3, right? This is the order which I have got for the column. So this is what I am going to push in the map. So whatever order I have got, this is what I am going to push in the map. Okay, so this is done. I have created the map by just giving this line of code. Now after creating the map, what I can do, now I need to create the answer vector, right? I can just create the answer vector. Okay, so how do I create the answer vector? I know the places where I should put the elements. Okay, so let me find the position, column position. Okay, column position of element, column position. How I can find it? By just seeing the map. So in the map I will try to see where should I place this element, in which column should I place this element. Okay, so what am I doing in this line? I'm finding the column position from the map. Okay, so I'm going row wise. In the first row I'm supposed to place 1, but where should I place 1 in the first row? I can place it in 0th column, first column, second column, third column. Where should I place it? I am not clear. I need to see from the map. So 1 can be placed anywhere in the first row, but according to column condition it should be placed in the 0th column, right? So it should be placed in the first row and the 0th column. So this I need to see from the map. So I will get, this value will tell me I should place 1 in the 0th column, right? So I will place it there. So answer of I of column position, okay, will be equal to row order of I. Okay, similarly for all the next elements I will do. Next time what I am going to do? Next time I will see the next element. What is the next element? 4. Where should I place 4? In the map I know that I should place it at the first column. So okay, let me write my matrix here, then only it will be very clear. Okay, so this is my 4x4 matrix. Let me write it. So what we are doing, in the first element we see 1 should be placed at the 0th column. So this is the first row, done, right? This is the first row, this is done. Now let us see the next element. Next element, we are seeing the next element is equal to 4 should be placed in the first column, right? So so we will place 4 in the first column. Okay, this is done. Now let's see the next row. Next row we have to place the element 3, but where should we place it? We have 4 values for this, right? Where should we place it? We should see the map. So map is telling us we should place it in the third column. So I will place 3 here. Okay, this is done. Now I should place the next element 2, but where should I place it? I should place it in the second column according to the map, so that it satisfies both the row and the column conditions. This is the thing, right? So this is the correct matrix. Now I can return answer. Okay, that's it. And by the way, I think I didn't declare answer here, so let me declare answer here. So vector int answer. Okay, that's it. This is done. Now let me run the code and see if it is working. There's some compilation error, all conditions. So here I have given spelling mistake. Let me run and see if it is working. There's some compilation error, undeclared identifier element. This is node. Okay, let me run and see again. Okay, let's submit. There need not be unique solutions. It's accepted. Thank you for being patient and listening.